Hi, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 academic students who are studying the measurement and geometry unit. This is part 1 of that unit where we look at two-dimensional measurement, and this is actually video number 4 in that series about this unit. And so far we have looked at, in previous videos, the basic shapes and what their formula are, the Pythagorean theorem, and a focused look at right triangles, and composite figures. So in this video, we're going to be looking at thinking and application problems. So these are problems that deal with the concepts of perimeter and area of two-dimensional objects, but the question will involve more than simply using the formula. So let's get an idea by looking at a specific question. So this question says that a rectangular field has a perimeter of 10a minus 6 meters and a width of 2a meters. And we're supposed to figure out what is the length of the field. So obviously this is a two-dimensional measurement question because it's talking about the perimeter of a rectangle. But instead of giving us a straightforward value for perimeter and width, we're given polynomial values. So the perimeter is given to us as the binomial 10a minus 6, and the width is given as the monomial 2a. So not only do you have to understand perimeter, but you're also going to have to work with polynomials to get the answer to this question. So what I want you to do is I want you to press pause in the video. Oops, where's my little thing? I want you to press pause in the video, do the math for this question, and I'll meet you on the flip side. So fundamentally, this is a question about the perimeter of a rectangle. So the perimeter of a rectangle looks like this. So sometimes formulas are useful, and in this case, in order for me to think clearly about this question, I want to think about what does it mean to say the perimeter of a rectangle. So we have some values. Now, technically these values are in polynomial form, but there are certainly things that I can sub into this formula. I have a polynomial that represents perimeter, and I have something that represents width. So let's do those substitutions into the formula. So perimeter is 10a minus 6. Still don't know length. Width is 2a. Length, width is 2a. So I have a polynomial over here, and I have the beginnings of a more familiar polynomial over here. So let's do some math that we are used to doing with polynomials. Let's collect some like terms. So on the left, I'm still going to have 10a minus 6, but on the right, I'll have 2l and plus 4a. So if I'm trying to find the length, then I want to be able to say length equals something. So length equals 12, or length equals 13a, or whatever length is. So my goal, once I've kind of dealt with the fact that I have polynomials, fundamentally, my goal is to isolate this variable L, because I want to be able to say length equals. So to isolate L, we're just going to do equation solving. So first of all, I need to get rid of the term 4a. And we know that to get rid of positive 4a, you're going to do minus 4a on both sides of the equation. So on the right side, 4a and minus 4a cancel each other out. I'm left with 2l. On the left side, I have 10a minus 4a. So that's 6a. And the minus 6 is still minus 6. So now I'm down to just 2l, and I want l. So to get rid of multiplication by 2, we know that I need to divide by 2. So when I divide by 2, on the right, I'm left with l. And over here, 6 divided by 2 is 3, so I have 3a minus 3. So the length of this field must be 3a minus 3 meters. And again, it doesn't matter that I don't know what a is, because I wasn't told what a was at any point. The perimeter is 10a minus 6. The width is 2a, and so now I know the length is 3a minus 3, and that's in meters. Okay, so you can see how this is still a two-dimensional problem, but there's more to it than just use the formula. Let's look at the next question. So in this question, we're told that a picture measures 30 by 15. So I guess this gray square here is 30 by 15, and it represents some picture. The mat around the picture is 10 centimeters wide. So 10 centimeters wide in all places, and it says find the area of the mat. Okay, so What I want you to do is, as before, I want you to press pause in the video, try to do the math on your own, and I'll meet you on the flip side. Okay, so for me to find the area of the mat, and again, that's just this white area here, how am I going to do it? Well, I want you to think of this as a composite figure. Basically, what I have is I have a large white rectangle, and then I've cut part of it away, and the part that I've cut away is also the shape of a rectangle. So to find the white area, what I'm going to do is I'm going to find the area of the entire rectangle here in white, and then I'm going to subtract the area that's represented by the picture in gray. So this is just two length times width questions. So let's look carefully at this white area. And we need its dimensions, obviously, in order to find the length, the area, we need length and width. So here is the length of that white mat. We know that this is 30, so what must this be? Well, we're told that the mat is 10 centimeters. So I have 10 plus 30 plus 10, so that would be a length of 50. And again, the same thing for the width. We know that this is 15, and then I have the mat here and the mat here, so this must be 10 plus 15 plus 10, which is 35. So multiplying those together, we find that the area of the entire number one white rectangle is 50 times 35, which is 1,750 centimeters squared. And that's the area of the first rectangle. Now the second rectangle, the part that we're going to cut away, is represented by the gray picture, and we were told from the very beginning that that was 30 by 15, and 30 times 15 is an area of 450 centimeters squared. And again, just to demonstrate, what we want to do is we want to subtract the picture area from the whole rectangle, because what we're left with is just the mat. So the area of the mat, oops, pen's acting funny, just a second. The area of the mat is equal to 1750 minus 450, which is 1300 centimeters squared. So again, a composite figure can be a figure that is not two things added together, but rather two shapes subtracted from each other. Good. So let's look at the next question. So in this case, we have Pablo is designing a rectangular flag that consists of three colored triangles. The picture below shows the colors of each of the triangles and the cost of each color material. So there's a section here, triangular in shape, that is red, a section that is blue, and a section that's green, and it's what's the total cost of the material. Okay, so once again, I'm going to ask you to press pause on the video, and I want you to do the math, and I'll meet you on the flip side. Okay, so this is a fairly straightforward question about the area of triangles. Please make sure that you look carefully at your diagram. You need to notice that these symbols here indicate that the top of the red and the top of the green portions of the flag are equal in length, and therefore exactly 50 centimeters each. So I started with the blue part of the flag, which had a base of 100 and a height of 50. And so calculating the area of that flag is 2,500 centimeters squared. And at a cost of 1 cent per square centimeter, that's a $25 cost for the blue part of the triangle. Then I went to the red part of the triangle, and again, I knew that it was a 50 by 50 base and height. So 50 times 50 divided by 2 gave me an area of 1,250 square centimeters for red. And at a cost of 3 cents per square centimeter, that's $37.50. The green part of the flag is actually identical to the red flag. It's just reversed. And so therefore, it's also 1,250 square centimeters. The cost of 2 cents per square centimeter, so that's $25 for green. And so to sum it all up, I have costs of $25, $37.50, and $25 for a total cost of $87.50. Okay, hopefully a fairly straightforward question involving triangles. So another question here, this is It looks like a perimeter question. It says a field in the shape of a trapezoid has a perimeter of 460 meters. A fence is being built along the perimeter. Determine the length of fencing needed for each side. So again, I'm going to press pause, ask you to press pause, do the math on your own, and I'll see you on the flip side. So clearly, again, I have a perimeter question. So let's write what we know about the perimeter. And again, perimeter is just add up the side lengths. So I'm just going to add up all the side lengths of this perimeter. And obviously, this is going to turn into a polynomial, an equation question. But it starts off with just an understanding that perimeter is the sum of the side lengths. Now, I actually know that the perimeter is 460. So instead of P, I write 460. So the perimeter, if I walked all the way around, I would walk 460 meters. And so that means that each portion is now represented. So here's the first side, here's the second side, there's the third side, and there's the fourth side. So let's start doing some polynomial math here in this equation. So for example, I'm going to multiply 8 times the bracket, so 8x plus 16. And I'm going to multiply 4 times this bracket, so 4x minus 8. And then plus 7x minus 8 plus 4x. So there weren't any other brackets. So I've done that part of the bedmiss. So now I don't have any other multiply to worry about. I'm going to start collecting like terms. So I have 8x plus 4x plus 7x plus 4x. So 8 plus 4 plus 7 plus 4 gives us 23x. Now 16 take away 8 is 0. So I'm not even going to write plus 0 because there's no point. So I'm left with 460 equals 23x. Solving for x, I get a value of 20. Now, just because I've solved x, that doesn't mean I'm done the question. Go back to what you're actually supposed to do. It says, determine the length of each side of fencing needed. So now that I have a value for x, I can substitute x into each one of these sides, and I can tell you the length of each side. So let's go ahead and do that. And I've just recopied that particular diagram down here. And now I know that x is 20. So this side here is going to be 8 times 20 plus 2, which is 8 times 22. And 8 times 22 is 176 meters. So just keep going around. This side here is 4 times x. So 4 times 20 is going to become 80 meters. This side says 7 times x, subtract 8. So 7 times x is 140. 140 minus 8 is 132 meters. And then finally, this side says 4 times x minus 2. So that becomes 4 times 18. And 4 times 18 is 72. Now, there's a very easy thing we could do to check our math, and that's obviously to add 72, 132, 80, and 176. And if we get 460, we know we did our math right. Okay, so there's one more question here in this section. So again, what I want you to do is read carefully through the question. It's about pizzas, so that's not bad. See if you can do the math without me. Press pause on the video, and I'll meet you on the flip side. Okay, so this is obviously a question about area. It says that these two pizza specials are the same price, and it says the pizzas are the same thickness. It says determine the diameter of the Galileo special if the two pizzas contain the same amount of pizza. So if I ate both of these and you ate this, we would have eaten the same amount of pizza. So therefore, I need to know the area of these two pizzas, and therefore I can tell you that it would be the same area. So that's the math we have to do. So the area of the Fibonacci specials is going to be 2 times pi r squared because there's two pizzas. So it's going to be 2 times pi times radius, 12.5 squared, which gives us 981.3 centimeters squared for the Fibonacci pizzas. Therefore, the area of the Galileo pizzas is 981.3, and that's going to equal pi r squared. So just solve for the radius. And you should get a radius of 17.7 and a diameter of 35.4.